Hello everyone, welcome to one new episode of Golang Cafe, and today we are going to implement the REST APIs without using any external framework or dependencies, just by using the Go standard library. It's going to be useful if you want to learn the basics of HTTP servers and how to implement a REST API in Go, and you can obviously then learn to use different frameworks which are based and built on top of the fundamentals that we're going to see today. So today's episode is about implementing a set of endpoints for our server, and the set of endpoints that we are going to implement are the following ones. I've already created a scaffolding for our exercise, but the set of endpoints are the following ones. So the endpoints are effectively three. So it's the get users, which returns a list of users. Then we have get users/id, which is returning a user by ID, and then is post users, which allows us to create a user. Everything is a JSON based, so it's a JSON based REST API. You could do that with XML if you want, but JSON is what we usually use when working with the REST APIs. Everything starts with the ServeMux, which is a type in the HTTP standard library, and a handler interface, which we're going to see in a moment. So the key parts are the ServeMux, which is the multiplexer that associates requests to respond to handlers in our code, and then we have the handler, which is the actual code that gets executed when certain requests are passed in our server. The first step that we are going to see is the HTTP handler, which is the interface that is important to us. The interface that is then going to be used in our ServeMux, and the handler response, it's an interface that implements the serve HTTP method, and that method receives a response writer and request. The response writer is effectively the response they are going to send to your clients, and the request contains all the information of the HTTP request, such as the URL, the method of the request, any headers, and anything that can be associated with the HTTP requests. If we now have a look at the ServeMux, which is the main type that we are using now, it's a request multiplexer, and that means that it matches a certain type of URLs and requests into a certain handlers, which are functions that we said. And those handlers are what we define here in our main file, and this is a basic example of that. So we create a ServeMux, which is our multiplexer. We then call the handle function on the multiplexer, which means associating a request to a specific handler. And then we call the listen and serve, which allows us to start our server. We specify an address, and then we pass the multiplexer there, which is an handler function. The multiplexer, as we just said, we can also have a look at the more specific documentation. We can do ServeMux handle, and then we would see that ServeMux has a handle with the pattern, which is a string, and then an handler, which is what we've seen before already. So we can use this one to effectively associate requests to handlers. So if we were to have, for example, posts, we could do the same here, and then we could do posts handler, and that would work exactly the same way. So all the requests starting with post would be routed into the post handler. All the requests starting with users would be routed into the users handler. Now we still have some work to do, because at this point we're gonna see that in the serve HTTP of the user handler, we're gonna have all the requests. We're gonna have the requests just to list the users. We're gonna get the requests for a specific user. We're gonna get the request to create a user, and so we need to do some work, some extra work here, in order to understand and see which request is mapped to which handler. We are gonna need to create three different handlers, one for each different method. So get users, list users, get user, and create user. We're gonna do that now, so that we already have this ready for when we need it. So user handler, and everything is part of user handler, because it's just handy for us to have everything in the same type. So it's list users, and then we have HTTP response writer, and then we have the request. A request is a pointer to request, and we can just basically copy all of this and this is list, this is get user, and get user, and then this is create, get and create. We can just remove users, list, get and create. We said now we need a we need to understand where we need to redirect this handler. So we need to decide the request, how to map the request to a handler, and we use the switch. In this case, you can use if else, you can use other things, but I think the switch is the cleaner way you can implement this use case. And we also will need a couple of regular expressions to decide to which handler we need to map our request and our response. So that's what we're going to do now. I'm just going to quickly create a set of handlers. It's just one for each different request type. So the first one is a list users regular expression, which is regexp, and then must compile. And then we have the starting anchor, the ending anchor, and then we say literally users, and this is optional because we may get the final slash or not. This is optional to us. So this is list users. This can be get user, and this can be create user. This get user, and list users. And that should be everything. So this one gets the this slash is not optional anymore, but this time we get an integer. We need to capture the integer. So this is basically users, for example, 1, 2, 3, and so we need to capture the integer at the end of that. And this is exactly like the create the list user. So that should do what we need to do. Now, in order to drive our switch and our decision, we need to see the method, and we need to see the URL path, the request path, and we need to match the request path against the regular expressions that we have just seen. The first one is going to be the list. So request of method is equal to HTTP .method get. So if it's a get, and if list users regular expression match string are URL.path, that means that we are in the list handler. So we need to do list. We pass the response writer in the request. We return in this case, and then we do case method. Now we want to do method get again, but this time we want to do get user regular expression match string. If the URL that we get is matching the regular expression for the get user regular expression, then we call the handler for get user, and then we return in this case. You always need to remember to return, because otherwise we're gonna process the request multiple times basically. And then the last one is a method is HTTP method post, and it's create user regular expression match string are URL.path. And then we have a create and the usual signature. And then now we have a default one, which is not found. We have a specific handler. We are going to create a specific handler for when we don't have any match. We can create the handler here, so we don't forget. And so we can also explore and see briefly how a simple handler is structured. Response writer, and then we have a HTTP request, which is a pointer to request. And in the case of not found, we want to write the status code, response status code, which is by using the write header method. And we use HTTP status not found, and then we can also write some message. Remember that the write method accepts a byte slice, so we just need to convert it from a string to a byte slice using this notation. We can just say not found here. We can just say not found. And this is effectively a standard handler that allows us to return a not found effectively. We can also do something more elegant, because we said that we are going to use a JSON REST API, so we want to reply in JSON. and so we're gonna say error not found, and we are going to set the response status, either set content type into application JSON, so that it's going to be JSON for each type of request, no matter what request path we get, is always going to be a JSON. So now we have the list. We need to list a set of users. The first thing that we need to do is we need to come up with a in-memory data store, just for our example, but you could have also a different type of data store, which can be, for example, a SQL data store or any other type of data store. For our example, we're just going to use a in-memory data store, which is going to be a very simple one. Data store is a struct, and our data store is a map that maps a string into a user object. So we need to define our user object, which is what we are going to then use for our JSON, and then we have also the name. You could have even more complex structures in here. It doesn't really matter what structure you have. It's just that you need to then convert that into JSON in order to show it into the response. And we're going to see in a moment how we can do that. And you always need to remember that, at least for the in-memory data store, because for other data stores the concurrency isn't really a problem because it's managed by the data engine. But in our specific case, the data store is something that it's concurrently accessed by different routines, and so we need to always remember to guard this with a mutex. In this case, it's a read-write mutex because sometimes we only read from the data store, sometimes we only write from the data store. So something efficient is using sync read-write mutex, which allows us to access concurrently this map. And this is our data store. So once we created the structure of the data store, we are going to add this store into our user handler data store. And we also need to initialize, obviously, into our user handler. So our user handler, we now initialize it, user handler, and the user handler takes store. We want to initialize that data store, which takes a pointer to data store, and the data store takes two elements. The first one is a map, and the map is a map from string to user, and the string here is, for example, a user ID, and the user can be ID is the same, and then we have a name, is Bob, for example, and then it takes a read-write mutex. And this is our sync.readWrite mutex. You also need to initialize it, and I think we should have almost everything, at least for the scaffolding. Another thing to keep in mind is that our multiplexer, our ServeMux, maps subtrees of requests into handlers, so we need to specify our pattern using, if we want to match only users without the ending slash, we need to specifically add the slash user without the ending slash, and it will match everything that is like users. If we want to match anything that is users slash and anything after the slash, then we just we can just add the slash here, and that will match every other pattern after this pattern here. So this is something that unfortunately there is not a lot of flexibility now. You can structure your regular expressions in your ServeMux, but this is just the way that the ServeMux is structured in the standard library. There is not a lot of flexibility, but this allows you to effectively decide how you can wire up your router. In other routers, in other libraries, all those regular expressions you can specify directly into the mapping, or you also have some other characteristics and other functions that you can use. But in our case, it's going to be quite simple and quite basic, that you can really understand how this works. You can just maps requested that are equal to users, and requests that are like users with a slash, and then have something else after the slash. So this is the user handler. Once we have done that, what we can do, we then implement the list for our user. The first thing that we do for implementing the list is having obviously the list of users that then we can JSON encode. So this is a slice of user, length 0, and capacity is going to be the length of the of all users that we have. and then we're going to basically acquire a lock, store read lock from our map. Then we are going to go through the users, range h store m, and then for each of those we're going to be users, append users, and then it's going to be u, and then we do h store, and then we do unlock, read unlock. And then once we've done that, we can convert into JSON bytes. We also have an error. We marshal the users into JSON bytes, so we see if there is any error. If there is any error, we say internal server error, and we also need to implement this handler here. And at this point, what we are going to do, we are going to write header, and we are going to say HTTP status OK, and then write JSON bytes effectively. So let's just implement the internal server error handler, which is something that we implemented already with the not found. It's just going to be slightly different. So it's going to be internal server error, and here is effectively internal server error. And here is status internal server error. So we have not found internal server error. So this is a handlers that you can reuse here and there, and that's quite handy. If you're using different tools, different libraries, you will see that those handlers will come handy already out of those frameworks. But it's interesting to know how those work under the hood. It's just basically writing to the response writer a specific set of strings and bytes. So once we know that we have our list, this is quite easy, just retrieving the list of users. We can also now go and check with the get operation and the get handler. The get handler, the first thing that we're going to do, we need to first effectively get the user ID out of the request, and we're going to do that with our regular expression, get user regular expression, find string ServeMux, I think, from our URL path, and if len of matches is less than 2, and less than 2 because the find string ServeMux, what it does, it uses the capturing group, which is the thing between those round parentheses here. So it attempts to find a string, in this case, at least specifically in this regular expression, we attempt to find a string that matches this regular expression. The first match is going to be the string, the whole string, and the second match is going to be what's inside the capturing group. So the interesting thing for us, the thing that we need is the item inside the second element in the array. But at least we need to get 2 items in the array. In the case that this doesn't match, although this shouldn't happen because we already ensured this on top of our server HTTP, but it's just for sanity check. We return not found, we return, and then what we do, we say, okay, now we have our user, and okay means that if it's found, we also need to acquire the lock, store lock, read lock, and then h store, which is our storage, and then we know that matches of 1 contains our user ID. If the user is not found, then we say not found, or rather we should say user not found more specifically, but just for brevity. And then once we have the user, we say actually remember to unlock the store before you return, read unlock. And once you read unlock, then here we need to just JSON encode the user. So it's going to be JSON bytes error, and JSON marshal, which is just convert an arbitrary object to JSON, and we do the same thing that we have done before, which is internal server error, and we pass the writer and the request, and we return. And here we do the same, so we do write header, HTTP status OK, and we write, which is, in this case, it's JSON bytes, so we don't need to do any conversion. So we've seen the list, so we just get the list of users, we marshal the user into JSON, and then we write the status OK and we write the JSON bytes. We do the same with the get using the from the regular expression to find the ID. We take the user from the store and then we return that as a JSON. Now we just need to create, so we need to accept a request payload, and then we need to return the request as a response. And the way that we do that is very easy. We just effectively need to use a JSON decoder, JSON new decoder. So we need to decode JSON because we assume that we are going to receive JSON request of body, decode into a user object, and if there was any error, then we are going to say that this is bad request, for example. This is bad request. This is something that we could reuse effectively. And then we return. We also need to declare our user, which is a pointer to user. And then actually just here, otherwise it's the same name. There's a collision of names. So once we decoded the user, we are going to actually also need to implement the bad request just quickly. It's the same as we have done before. We just need to change the name here. Instead of not found, it's going to be bad request, and the status is going to be status bad request. So it's quite easy to then reuse requests. And then once we decoded the user, we are going to add the user into our data store. So we need to store, this time it's not just read lock, is lock, and then h store m, and then the user ID, and then the user itself, h store unlock. And then what we're going to do is the same as before, error. Although we already have the user as marshal the user. Although we already have the user as a JSON, we are converting back to JSON. But this is just something that, this is just something to illustrate that we're going to always return JSON. And we could also remove it, but we also need to then do some validation at some point here. So it's always handy to validate the user. Then we may add some other information, like for example created at, or some other info, and return that back into the user. Or the model can be different. For example, you can have a different model for accepting the request and a different model for returning the response, and so you will need to marshal your object anyway. You can expand that as you please, so there is a lot of flexibility on that. And here we do the same we have done before. So it's write header, which just writes the status code, status OK, and then you write the JSON bytes. And I think this is pretty much it. Let's see if it runs main.go. It should define regex. We just need to import the missing packages. And this is okay. You cannot use type user in assignment, line 94, line 94, and line 29. We don't actually need a pointer to user. And then line ServeMux is new ServeMux, go run main.go. Okay, so it looks like now it's working. Now what we're going to do, we are going to just remove this, and we're going to open here, and we're going to call our users, and we see that now we have Bob, which is the first one. Let's try to first get Bob 1, and that's working fine as well. And let's try to get something that doesn't exist, it says not found. Let's try to this is probably also not found. This is the default not found page. So users 1 we said it's Bob, users 2 is not found. If we want to create a new one, we create a post request. Remember to add content type application JSON data, and you have the ID is 2, and the name, actually the ID can be, yes, ID is also string, the name is also string, Karen, and then HTTP localhost and 8080 users. And now if we get users, we're gonna get Karen. If we go Karen, if we get again the users, we're gonna get a list of users again. As you can see, the list of users. Let's you can also see this better if we go back here and we close this down and we do the same that we've done. And here you can see is our API. Let's see that if we can also add a new one. So let's add a new one just to test if everything is it's alright. So now we have Karen, Joe, and Bob, and everything should work alright. Well, that was the REST API. I think that covered pretty much everything. So we just created 3 endpoints. We use the ServeMux, which is a request multiplexer that allows us to match requests to specific handlers. We used the handler HTTP handler with the serve HTTP function, which allows us to respond to specific requests and create a response to those requests and create new responses. And I hope you liked the tutorial and see you in the next one. Thanks for watching.